Alright, welcome to our part 2 of LSTM lesson, and let's continue and let's look at this part. We have 4 lines here, and the purpose of this code segment is to create compiled and train a simple long short-term memory neural network model for predicting the remaining useful life of machinery based on sensor data. And this model uses time series data to make its predictions. And here model sequential, it initializes a sequential model, and the sequential model is a linear stack of layers, making it straightforward to add layers one after another. And model add masking and mask value input shape. And what is this second line? It adds a masking layer to ignore padding values, and the masking layer tells the model to skip any time steps where the input is equal to mask value, which is used to handle sequences of different lengths by padding shorter sequences. And here LSTM 32 activation 10H. What is this? It adds an LSTM layer with 32 units, and the LSTM layer is a type of recurrent neural network layer that is capable of learning long-term dependencies, making it suitable for time series data. And here, where is okay, 10H activation function helps in maintaining the output values between -1 and 1. And here, model at dense1. What is this? It adds a dense layer with a single output unit, and the dense layer is a fully connected layer, and since this is a regression problem predicting a single value, it has one unit, one output unit. And here we compile the model. You can see the details and parameters here, and what we can say. Let's look at the output and talk about. We have a 5 epoch here, and you can see the decrease in the epochs like that. For example, in the last epoch, we have a low value for validation loss, and the model's performance improved significantly over the 5 epochs as seen by decreasing loss values, and both training and validation losses like that. You can see it shows that the model is learning effectively and generalizing well to unseen data. And here we will plot the history, and you can see train and validation is close here. And then again we will do some predict, and you can see the train test set RMSE and R squared values. Here for train set RMSE is 17, test RMSE 29, and again we will compile our model, and let's look at the epoch 20, and our here values are decreasing like that, and the model is learning and improving, and you can see. And again we will plot the new history, and here train and validate values are so close at 20 epoch. And again here we will do some predicts, and train set RMSE here 15, and test RMSE, and it is 28. And you can see the our values are improving, and it is good. And what we can say, let's switch and let's talk to another parts, and let's stop our alpha list, and we will talk about them and what happens here. Let's talk. This code snippet is setting up hyperparameters for the grid search to optimize machine learning model, And let's look at this alpha list. What is this? Learning rates for the model and 0.01, 0.05, and values from 0.10 to 0.60 in increments of 0.10, and sequence list here, sequence lengths ranging from 10 to 40 in increments of 5, and here third line epoch list, the number of training epochs ranging from 5 to 20 in increments of 5, and nodes lists here, different configuration of nodes, units in LSTM layers, and you can see the values here. And what we can say, another dropouts here, dropout rates to prevent overfitting, and here activation function 10H and sigmoid, the activation function used in the neural network. And let's switch, and what is this next? Batch size list, batch sizes for training the model, and here sensor list, different combinations of sensors to be used as input features, and tuning options. What happens here? It calculates the total number of combinations for the grid search, and this is the product of the lengths of all hyperparameters test. And in simple terms, this code is preparing to find the best settings for a machine learning model, and think of this setting as different combinations of ingredients in a recipe. And I think it's okay. And let's switch another part, and what happens here. Actually, you know that part, but let's talk again. First, clipping remaining useful life values here. Design ensures that any remaining useful life values greater than 125 are set to 125, and this is a way to handle outliers and extreme values which might secure the model training. And let's look at the function of prep data and arguments, training dataset, and testing dataset, and drop sensors, list of sensor columns to drop, and remaining sensors here, list of remaining sensor columns to use, and alpha here, smoothing factor for exponential smoothing. And what we can say, another dropping sensors, you know that part, sorry, it drops the specified sensor columns from the training data set, and test drop, I talk about these two lines, and it drops the specified sensor columns from the testing dataset, second line, and adding operations adds operational condition information to the dataset. And again, scalar part with condition scalar, it scales the database on the operating condition to normalize it. And exponential smoothing part, you know that it applies exponential smoothing to the sensor data to smooth out noise and make patterns more prominent. And this function prepares the data by cleaning, normalizing, and smoothing it. It ensures the machine learning model receives high quality, consistent input data, which is important for accurate predictions. And let me switch. And what happens here? We have another function called create model. And let's look at the parameters. First, input shape of the input data, and nodes per layer, this specifying the number of nodes in each LSTM layer, and dropout rate to prevent overfitting, and activation function to use in LSTM layers, and weights file path to save the model weights. And model initialization here with sequential, it initializes a sequential model, and here model at masking masks the input data where the value is -99, and we add LSTM layers. If there is only one layer specified in nodes per layer, it adds a single LSTM layer. And if there are two layers specified, it adds two LSTM layers with a dropout layer in between. And what we can say, dense layer, it adds a dense layer with a single neuron to output the prediction. And finally, compile part. It compares the model with mean squared error loss and Adam optimizer, and it saves the initialize ways to a file, and it's okay, I hope. And what happens here, let's explain and let's talk about. Okay,